Hello guys, this is the MEPtutor and in today's video I'll be solving this problem. The problem is a question: which of the following is a one-to-one function on the given domain? We have 5 different functions, each one with a different domain. So let's do it. But first, what is a one-to-one function? A one-to-one function or an injective function is a function that, okay, let's draw two sets, okay, set A and set B. Each of these sets have 3 items, for example. It will be, the relationship between these two sets will be an injective function or a one-to-one function when each of the items of the group A have a different image on the set B. This is the contrary of a non-injective function or a many-to-one function. Again, we got two sets, set A and set B, each of them with 3 different items. In this case, imagine that 2 different items have the same image, 2 or more than one. If more than one of the items from the first set have the same image on the second set, this will be a many-to-one function. So we are looking for an injective function. Injective, very complicated word. So let's analyze one by one, starting with the function A, y equal to cosine of x. Cosine of x. All right. The graph of the cosine of x, it's something like this. It's an artistic representation of the cosine of x. Very beautiful, but not very exact. The given domain is from minus pi divided by 2 to pi divided by 2. So the function we're going to analyze is only this piece of the whole function. This function is infinite. When, okay, let's grab blue color. When x is equal to 0, y is equal to 1. When x is equal to pi divided by 2, y is equal to 0. When x is equal to pi divided by 2 minus pi divided by 2, y will be 0. So there are 2 items on the first set that produce the same item from the second set. So this is not a one-to-one function. It's not injective. It's a many-to-one function in this given domain. So let's continue. Y equal to sine of x. Okay. Now the graph of sine of x will be something like this. It goes, all right, something like this. It's less exact than the last example, but okay. Here it is. And the chunk again is from minus pi divided by 2 to pi divided by 2. So the chunk of the function will be something like this. This is the point 0, 0. This is the point of pi divided by 2. And y will be equal to 1. This point is minus pi divided by 2. And y will be equal to minus 1. So there is a general method to identify if a function is a one-to-one function. If we draw horizontal lines everywhere, anywhere, if at least one of the horizontal lines cuts the function, the graph of the function, at 2 points, at more than 1 point, 3, 4, that will mean that the function is not a one-to-one function. Here in this case, this chunk, this red chunk with any horizontal line will be only cut at one point. So this is a one-to-one function. So the answer of the problem is letter B. But okay, we finished the problem. But we are going to analyze also C and D to see if, I don't know, just for curiosity, y equal to x to the cube minus x. Okay, the graph of this will be something like this, and the chunk we're analyzing is from -1 to 1, from here to here. This is the chunk we're analyzing. Okay, if we draw a horizontal line exactly, a horizontal line that is basically the x-axis, this will cut our chunk of the function 3 times. So this is definitely not a one-to-one function, it's a many-to-one function. And those 3 points are -1, 0, 0, 0, and 1, 0. The final function, y equal to the absolute value of x plus 2. Okay, the graph is something like this. Okay, all right, something like this. And it goes from -4, it goes to 2, something like this. Okay, all right. When x is equal to -2, y will be equal to 0. When x is equal to -4, here the point will be -4, 2. Here the point, if x is 2, y will be also equal to 2. So there are 2 points. And if we observe, we can draw more horizontal lines and they will cut our chunk of the function more than once. So this is also not a one-to-one function. It's a non-injective function. So the problem is solved and the answer is letter B.